Hello, I'm Nikhil and my groupmates are Kushan and Benjamin. We're from Group 1 and today we'll be exploring the data set of laptop prices. We'll go through our problem statement and then delve deeper into the data cleaning and preparation we did, followed by our machine learning algorithms and lastly the predictive analysis and conclusion. So, our problem statement and goal for this project is to analyze the extent of impacts of different numeric and categorical variables on laptop prices and which affect price the most. We also use machine learning to analyze which laptops have the least and most value for money. We'll first talk about data cleaning and preparation. To begin, our dataset laptops is from Kaggle. There are 991 rows and 22 columns indicating 991 different laptop models and 21 features of the laptop excluding index. We had 4 steps for our data cleaning. The first step is variable selection and preparation. We are finding out which factor affects the laptop price the most and decided to go with these 3: brand, processor brand, and RAM memory due to their significant influence on the price and performance of electronic devices. We extracted 3 columns into 3 bars. For processor brand, we identified there were a total of 4 unique processor brands, but there is only 4 counts of other. We have decided to remove them because these represent unpopular or unspecified processor brands, which could introduce bias or inaccuracies into our analysis. We have chosen to remove brands with 6 or fewer counts from the dataset to ensure that our analysis is based on the brands with a more substantial presence. This filtering process helps maintain the dataset's integrity by focusing on brands that are more representative of the market landscape. For RAM memory, removing unique RAM configurations with low counts can distort the dataset's representation and adversely affect modeling, so we chose not to remove them. In total, we have removed 41 entries, which account for 4.13% of the whole dataset, and this is still manageable. Next, we remove duplicate and null values, but as you can see, there is no null values here. There is no duplicate values as well, so we did not have to remove any more entries. For the third step, we encoded categorical values to prepare our data in the case where our model or analysis methods only allow numerical data. We decided to use one hot encoder for this. This model encodes each category values to 1 and 0 value as a notation for true or false. We encoded 11 brands and 3 processor brands to one hot numeric arrays. After concatenating the encoded variables with price and RAM memory, we now have a new data frame 3 vars now. Lastly, we converted the 2 data frames to pickle file for easy collaboration and to do the rest of the project smoothly.
Now let's talk about the exploratory data analysis that we did. So we split into 2 portions, the individual data distribution of all data, as well as the statistical inference. First, let's visualize the individual distribution of our data across all variables. We plotted histograms with kernel density estimation curves to have a smooth visualization. We can see that the distribution of processor brands, the majority belongs to Intel. For RAM memory, since the data is in multiples of 4, we see spikes at 8 and 16 gigabytes especially, with much lesser values at 4, 32, and 36. Brand is relatively more spread out, with majority of the data being at Asus, Lenovo, HP, Acer, and Dell, and the KDE provides us with an easy representation of the spread of the data. So as to further our statistical reference, we use box plots as visual aids. We can now clearly see the difference in the mean prices of the different processor brands, and even more so, we can see the trend of the increase in the mean price to the different RAM capacities. The brand box plot also shows how different brands have evidently different mean prices. To further our visualization, we use strip plots instead of swarm plots so as to encompass large amount of data as seen by the processor brand, RAM memory, as well as brand strip plots, which provide us with a clear representation of how different data in each variable varies at certain prices. After getting a clear picture of the data spread, we now delve right into the linear regression models to see which brand affects the price of the laptops the most. We first split the data into train and test data using a 75 to 25 split. Since the RAM memory is a numerical value, we do have a confusion matrix to get a correlation coefficient, and we can now see the moderately strong positive linear relationship that RAM memory has with price. We do have a bar plot to further prove this and see that for the most part, price increases as RAM memory increases. We plot out 2 linear regression scatter plots using train and test data, and we note that it may not be the best linear model to account for the relationship. Keeping this in the back of our minds, we go on to think, how can we analyze the relationship between categorical data and price? And we decide to use the ANOVA test, an effective and flexible way to assess whether there's a statistically significant difference between the means of our categorical variables. This is the ANOVA test result of brand, and this is the ANOVA test result of processor brand. As seen by the extremely low p-value of brands and of processor brands, we determined that the difference in the price of laptops can be attributed to the difference in brands and processor brands respectively. To visualize this, we plot out bar graphs of the mean prices of different brands, as well as bar graphs of the mean prices of processor brands. Nonetheless, the data still does not provide us with a clear answer on which variable affects price the most.
We then implemented the random forest regression method. The random forest model provides insights into feature importance, indicating which features are most influential in predicting the target variable. At the end of the model, we calculate and display the feature importance scores, allowing us to understand the relative importances of each feature in our prediction task. In this model, we leverage machine learning techniques and feature importance analysis. Through this, we gain insight into the factors driving price variations in our dataset. From our comparisons between RAM memory, brand, and processor brand as features, we found that RAM memory has the highest importance. And therefore, we can say that it has the greatest impact on price. By also implementing the random forest on individual variables, we can see which of the different computer parts from different brands have the greatest impact on the laptop's price. After comparing the feature importances of processor brand, we find that Apple processor brand has the highest importance and consequently it has the greatest impact on price. We also conduct this on the brand variable, and from this we can see that the brand of Apple has the greatest impact on the price of its computers compared to other brands. Lastly, we also use the model on the total feature importance across all of the three variables that we have chosen. From this comparison, we can see that the top three importance ranks are held by RAM memory. Therefore, we are able to conclude that the variable that has the greatest impact on price is RAM. So now, we'll use clustering to affirm or disprove our earlier hypothesis made by Benjamin. Firstly, we have to determine what is the optimal number of clusters. We can do this through elbow method and silhouette score. For elbow method, we can pinpoint the optimal number of clusters by plotting the inertia, which is the within cluster sum of squares, against the number of clusters and identifying the elbow point where the rate of decrease slows. As you can see from the graph plotted here, the rate of decrease slows down at 2. For silhouette score, it provides a concise measure to determine optimal number of clusters by considering both cohesion within clusters and separation between clusters. It identifies configurations where objects are well matched to their own clusters and distinctly separated from their neighboring clusters. As you can see from this graph here, the score is highest at 2. With both of the elbow method and this silhouette score, we decide that 2 is the optimal number of clusters. Let's now dive into using clustering algorithm, k-means clustering, to identify underlying patterns and group similar data points together. We can see that the points are separated mainly by price, with cluster 0 consisting of higher priced laptops and cluster 1 consisting of lower priced laptops. There is 845 points in cluster 1 and 105 points in cluster 0. As you can see here from this information, in cluster 0, it consists mostly of laptops with 32 GB and 36 GB RAM memory, and the rest of it is mainly in cluster 1 based on the percentages shown above. So we can confidently support that RAM memory affects the price the most.
Now that we have determined which variable is the most influential on price, we can use predictive analysis to see whether we can determine the prices of laptops using predictive modeling. We use three machine learning models, which include linear regression, random forest, and gradient boosting, to train models and make predictions on the price of laptops based on their RAM memories. As we can see, the different ML models do not provide us with an accurate judgment of the prices based on RAM, and hence we conclude that predicting prices solely based on RAM memories would not be the best solution, and we have to factor in other numerical values. We then decide to see which laptop brands are most worth and least price worthy. And we formatted a question of whether a higher price means that the laptop is also highly rated. We first plotted a scatter plot to see the spread of mean prices against mean rating of each brand, and it can be observed that the data generally follows this line, except one anomaly indicated by the arrow, which is Apple. We then also plotted a polynomial regression model to double check, and we can see the drastic drop in rating, although the mean price is much higher for Apple. For most of the data, it can be observed that a higher price will result in higher rating, with the exception of the anomaly of Apple, which has the lowest mean rating, but ironically the highest mean price. We would suggest purchasing laptops from LG or MSI, which have the highest ratings at a mean price that's much lower than that of Apple. With that, we've come to the end of our presentation. Thank you.